For many phenomena, an amount A varies with the time t according to the following formula. Whenever you see these keywords like compounding, continuously, you will use this formula, okay? So A, the amount A equals P times the principal amount, the initial amount, times E raised to the R times T power. Here, P is the amount at time T equals 0, and R is a non-zero constant. R is going to be the rate, and E is the natural logarithmic base. If R is positive, if the rate is positive, then A increases over time, and we have a continuous exponential growth model. If R is negative, then A decreases over time, and we have a continuous exponential decay model. But we're going to start with this formula. I'm going to start with this formula. Whenever we run into this keyword, compounding continuously or continuously compounding. So let's look at some examples together. Number 3 says, a number of bacteria in a certain population increase according to a continuous exponential growth model. Continuous exponential growth model. So whenever you see this, you will write down A equals P times E raised to the R times T power. But because I mentioned growth, I know rate is going to be positive. It says with the growth rate parameter of 2% per hour. What you want to do is convert this 2% into decimal. So R is not 2, but 0.02. Just divide that by 100 to convert it into a decimal. How many hours does it take for the size of the sample to double? After solving this problem, I will give you a formula called doubling time, okay? There is an easy formula that you can use, the doubling time formula. And we can use that to come up with tripling time formula or quadrupling time formula. But let's start with just some random numbers first, okay? Let's say that you have one bacteria. Let's say we start with P equals 1, okay? It will get doubled when A equals 2, right? Now, I just picked 1 and 2. You could have picked 5 and 10 or 100 and 200. Doesn't matter as long as you double, that's okay. Because they never really said how many bacteria we are starting with. So I'll say 2 in here, 1 in here, and then I'll say E raised to the. Now the rate was 0.02, and I'm multiplying that by T. We're solving for T here. So look, I can divide both sides by 1, right? And just get 2 equals E to the 0.02T. And you will get 2 on the left-hand side, no matter what P you started from, because you get the other side, A, by doubling what you start with. Now, I left some room here because I want to take, I'll write ln on both sides. I'm going to take natural log of both sides to bring down that exponent. So this equation will turn into natural log of 2 equals 0.02t. Okay, because natural log and E becomes just 1, well, before it just becomes 1, I can just bring this exponent of 0.2t down in front. That's one of the log properties that we use, right? Okay, last step is to divide both sides by 0.02. Okay, and this is where we're going to have use a scientific calculator. Okay, I'm going to divide natural log of 2 by 0.02, and that comes out to be 34.6. I'll write it again. Came out to be 34.66, and I should go check the unit. Is it years, month, hours? Oh, the time unit is in hours. So it's going to take about 35 hours for the number of bacteria to be doubled if it has a 2% growth rate per hour. So here's a doubling time formula for you, okay? You don't have to solve it every time you are asked to find the doubling time. The doubling time, t is equal to natural log of 2 divided by the growth rate, r, okay? Then that's what we ended up doing, right, when you solve that equation. So if you're looking for a tripling time formula, that will simply be natural log of 3 divided by r. If you're looking for quadrupling time, you will do natural log of 4 divided by r. But that's how you can easily find doubling time, okay? And that's just from solving an equation by setting the other side twice as big as the initial. Let me do one more in this video. I think I have another very similar example. Suppose that 1,400 is initially invested in an account at a fixed interest rate. Oh, look, keyword, compounded continuously. So as soon as I read that part, I'm going to write down A equals PERT, P times e raised to the RT power. And I know what P is. P is given as 1,400. That's the initial investment. What else? Suppose that after 5 years, so T, the time here, is 5 years, the amount of money in the account is, so the ending amount is 1,774. So the money grew a little bit. Find the interest rate per year. Write your answer as a percentage. Round percentage to the nearest hundredth. Okay, so let's plug in everything we are given. So on the left-hand side, let me put 1774. On the right-hand side, let me put 1,400 times e to the, r is unknown, but t is 5. So I'll write that as 5r. Now let's solve this for r. First, divide both sides by 1,400. You see, the previous problem, when we did the division, we ended up getting 2 here. But now we're just going to have to keep on writing this big fraction, 1774 over 1,400. And the right-hand side is e raised to the 5r power. Now, I'm going to bring down that 5r by taking natural log of both sides. So let's take natural log of that fraction on the left-hand side. All right, hold on. Let me move this a little bit to the side so that I can put ln in front of it, okay? Natural log of 5 e raised to the 5r power. So if I do that, that 5r will come down. So the next line, I'll write down natural log of 1774 over 1,400, and that equals just 5r, because natural log of e will turn into 1 once that 5r comes down. So what is the very last step? I just need to divide both sides by 5 to find r. All right, let's find what r is. And r is going to be in decimal, but since they want us to find percentage, I'm gonna go ahead and do this division, and I will multiply by 100 to convert it into a percentage number. So look, I have natural log of 1774 divided by 1,400, and then I'm dividing this big natural log expression by 5. So that's r. We found r. r is 0.0474. But if I want to convert this into percentage, I'll go ahead and just multiply by 100. So they said round to the nearest 100th percentage point. So the answer is going to be 4.74%. Okay, so when we first saw these problems, I think around section 3.4-ish, we were just plugging in maybe P, R, and T, and we're finding the A value. But in this section, we're working backward. Okay, we're looking for either the T, the time variable, time, or the rate. So we're solving for exponents. That's why we're doing these after we learned how to solve exponential equations. Because I went over 2 examples here, I will go ahead and stop this video, and I'll come back and show you how to do, very similar problems, but, just asking a slightly different ways.